Hi and welcome to tutorial. In this tutorial, let's learn how to perform data querying. So let's begin with data querying using joins. Here, cross join and join types are similar to inner join. So inner join is used to link a table to itself. Consider these two tables, T1 and T2. Let's try inner join now. Suppose we say select star from T1 inner join T2. We can see that inner join performs Cartesian product. Let's try inner join with some where condition. Suppose we say select T1 dot star T2 dot star from T1 inner join T2 based on the condition that T1's I1 should be equal to T2's I2. So here we get the answer. We can see that inner join selects only those records where there is a match condition. In order to select even those records where there is a mismatch, we can use outer join. Let's try left join. In left join, we get the result set that contains a row for every entry selected from left table. Suppose we say select T1 dot star T2 dot star from T1 left join T2 based on the condition T1's I1 is equal to T2's I2. We can see that outer join places a null wherever there is a mismatch. Let's try right join now. Right join is exactly similar to left join except that this forces the result set to contain a row for every entry selected from right table. Let's check it out. Here we can see that it places a null whenever there is a mismatch. We can also use left join to find the records where there is a mismatch. Let's try this. Select T1 dot star from T1 left join T2 based on the condition, same condition, T1's I1 is equal to T2's I2, where T2's I2 is null. So we get this output as a result. Joins can also be used for self-referencing. Let's understand this using this EM table. Consider this EM table. Suppose from this table we want to retrieve employee table separately. We can use self join, that is, we can use inner join. Let's see. Select T1.ssn and T1's name as employee name from EM table as T1. We have to perform inner join here. Inner join employee manager table as T2 based on the condition T2's SSN is equal to T1's manager SSN. So here we get employee table separately. We can also get manager table in the same way. Now let's understand how to use union operator on data querying. Consider these two tables for team 1 and team 2. So now let's perform union operator. Say select Let's select name and age. From team 1, union, select name and age. From team 2. So here we get the answer for union. In order to preserve even the duplicate rows, let's use union all. So select name age. From team 1, union all, select again name age. From team 2. We can see the difference here. Union all even preserves duplicate values for Sam. So Sam is repeated twice. Aggregate functions now. Aggregate functions are used to perform calculations on group values, and these return a single value. For example, take this employee data table. Let's try sum function now. Sum returns the sum group values. It returns 0 if there is a mismatch. Suppose from this table we want to select the sum of all the salaries. So if we can say select sum of salary from E, we would get the sum as 45,000. Suppose we want to find the average of all salaries, we can use the function average. Average salary provided by the company. So we'll get the answer as 15,000. Suppose we want to count the number of employees working in the department, working in the company. So we can use count function. Select count of star from E table. So we would get the number as 3, indicating that there are 3 employees working in the company. Suppose we want to find the minimum salary and maximum salary provided by the company, we can use the functions min and max. Let's try this. Suppose we say select min salary and max salary from employee data table. We would get the answer as 10,000 being the minimum salary and 20,000 being the maximum salary. Let's try variance function now. Suppose we want to find the variance of salary, we can use variance. Variance of salary from employee table. Here we get the variance of salary. We can also use standard deviation function. Here we go. Let's understand views now. Views are the virtual tables defined in terms of other base tables. In order to understand views, let's again use the employee table. In this table, if we want to only select the column names and SSN, we can create a view as, use the syntax for create view, create view, view name, let's set as view employee, as select SSN and name from employee table. Query is okay, so the view is created. Let's check if the view is created or not. So if we say select star from the view, view name, view employee, we would get SSN and name value separately as the view. We can also provide column names explicitly. Let's try this. Let's create second view. Let's set the names as register and ename, as select, SSN and name from employee table. Query is okay. So here we can see that the names are explicitly set as register and ename. Those can also be used to perform calculations automatically. For example, we can create this view experience 1 in order to find the experience of each employee by subtracting his date of join from the company's beginning date. Let's see if the view is created properly. Select star from employee experience 1, that is the name of the view. So we get the experience of every employee. We can further grant privileges to views using grant and revoke functions. We can also use alter view or show create view or drop views using the syntaxes. Let's try subqueries now. Subqueries support one select query to be nested within the other. In order to understand subqueries, let's again use this employee data table. Suppose we want to select the employee who is least paid, we can write the subquery as select star from employee table, give the condition where salary is the least. Salary is equal to, again select, find the minimum salary from employee. So let's learn how to use subqueries with all and any operations. These are used along with comparison operators. These are used if we have to test the comparison value satisfies a particular relationship with all the values written by the subquery. Let's try all operation now. If we say select SSN name from employee, where date of join is less than or equal to all, so select date of join from employee table again. This shows that Jack is the most experienced working employee. Let's try the same expression with any now. This returns all the rows because every date of join is less than or equal to at least one of the other date, including itself. Let's try subqueries with exists and not exists now. These are used to test if the subquery returns any row. If it returns any row, exists become true and it returns 1. Otherwise, it becomes false, then it returns 0. Let's give a true condition now. Suppose we say select exists select star from employee, where SSN is equal to 101. We have an employee with SSN 101, so this should return 1 because the condition is true. Yes, this works perfectly. Let's give a false condition now. Let's give a wrong SSN. So this is an error, so it returns 0. In order to understand subqueries with in and not in expressions, use this table EM. It's an employee manager table. Suppose from this table we want to retrieve all the details of employees who are working as managers, we can use select star from employee manager table where SSN in is operation. Select manager SSN from employee manager table. So this gives the result and we can find that Shalini and John are working as managers. So in order to retrieve details of all employees who are not managers, we can use Norton. This shows that all other employees except for Shalini and John are working as employees and not managers. So that completes a tutorial. We completely understood how to write subqueries using joins, unions, conditional operations, comparison operators, subqueries using in, Norton, exist, any, all, etc. Try more examples in order to understand these topics clearly. Visit further tutorials of your choice and browse through it. For further help, visit us at www.dataminingtools.net.